afternoon. I'm Chiao-Jo from National Taiwan University, and my advisor is Dr. Yan Fuguo. So today I will be sharing my work on building a system to automate the voice counting and the gender identification. So let me start with a quick introduction. So parasitic wasps in Taiwan plays a key role in sustainable pest control. And we are working with a kind of species which called Chiao-Jo species. A wasp used to control the citrus pests like Rhinocoris humilis, which attacks lemons and limes in Taiwan. And in our case, only the female wasps have the ability to parasitize the pests. So knowing their gender is essential in this case. And the photos here above you can see is the pest, the green one, and the crop damage it causes, and the wasp parasitizing the house eggs. And making a clear why accurate identification matters is a personal lab research and biological control efforts. And let's take a closer look at how we identify their gender. So as I mentioned, we work with the Chiao-Jo species. It's a tiny wasp about like the 1 millimeter long, and the way we identify their gender is observe their antenna, especially their clava segments. And here's, I think it is obvious to see the difference between the male and the female. Female has a larger clava segment than the male ones. Although it might seem simple to identify their gender based on the features that I talked about, but in reality, it's not easy as we think. So in the past, researchers identified and count the wasps manually under a microscope, which requires a trained personnel and took a lot of time. So for example, processing one batch around like 390 wasps requires about like 390 minutes, roughly like 1 minute per wasp. So this creates a major bottleneck in large-scale experiments, and also it's why important to automate the whole process in this research. So we set out to build a system that automates the process, and our goal is to detect and count the wasps and also classify their gender. And that way, we will help to reduce researchers' workload and also bring more consistencies to the process. And now let's get into how the system works. And I will start with a quick system overview and show the model's performance. And how do we actually automate the whole process? So in my system, it follows a two-stage pipeline. So in the first stage, we use the YOLO V7 to detect the wasps in the high-resolution scan images. And then we will go into the second stage. We classify the gender of each detected wasp using the ResNet 18. And this two-stage setup method matters because the raw images are huge, almost like 4,000 by 4,000 pixels. And processing entire image at once will be inefficient for the research. So by detecting the wasp first, we reduce the computational load and focus only on the relevant regions for the classification. So here's our first stage, the detection. We first downscale the image to 1120 by 1120 pixels to speed out the inference. And YOLO V7 will find the wasp, and we will map those positions back to the original high-resolution scans. And each detected wasp is then cropped and placed at the center of a 640 by 640 image with padding without resizing the wasp itself. And as a result, we achieve a mean accuracy precision of 99.4% in the wasp detection section. And for the next stage is the classification. So each crop wasp is labeled as a female, male, and unrecognizable using ResNet 18. So even with the subtle differences, the model performs also well enough. It's achieved at 96.74% overall accuracy. So, and also I put my confusion matrices on the top. So most wasps are classified correctly with very few misclassifications. And to wrap up, my system automates both wasp count, wasp detection, and gender identification, so reducing the workloads by about 91% compared to the past. So this helps entomologists work more efficiently and support future biological control research. And lastly, I would like to thank the Myeongdong District Agriculture Research and Extension Station in time for their providing their data and also their support. And this project was also motivated by real world needs from the collaborators from there. And thank you for all to being here to listen to my presentation, and I will be happy to take any questions.
Thank you. We have 1 minute for question.
Sure.
May I know what are the classification models you use?
My classification model is Resident 18.
Okay. So along with the accuracy, did you see the precision, those values, the other?
Oh, I didn't put on it. I only put the overall accuracy, but yeah.
One question, sorry. Did you validate this with a separate trial, like the models on independent means to see how the model performed?
Sorry.
Like a separate validation. Like I knew you predicted on the actual images, but a separate test performed as well to see how it responds to unseen data.
Did you validate the model?
Yeah.
Oh,
Did
I
you-
do.
Okay.
Yeah. Good. So we have the system is already in use for the entomologists, and although I put the result for only my Chinese details, but we already the overall accuracy in reality is like 94% accuracy. I think it's good enough for the entomologists to do also help their research. Yeah.
Great, thank you.